Good morning, everyone. Am I audible? Good morning, good morning. So how are you? It's good morning. Yuvraj, Nakshatra, Dara, good morning. Janki, good morning. Akshara, Srija, good morning, everyone. So you woke up. Great. Good morning, good morning. Hansika, I'm good. How are you? Fiona, I'm good. How are you? Good morning, good morning. Namaste. Good, I am also good. Yes, I had breakfast. What about you? Did you have your breakfast, Pooja? Yeah, yesterday was the exam. And yesterday was the NEET exam. So NEET exam is it's good. See, the main funda of exam is what? To get the marks or to get the rank. In the NEET exam, what you prefer? What you prefer? To get the marks or to get the rank? Uday, marks. No, you are wrong. Marks is not main thing. Russell, you are right. Rank. Yes, rank is the most important part. Rank is the most important thing. Because if you are talking about the marks, if your marks is 680, your rank is 1. Let's say your rank is 1 after scoring what? After scoring 680 marks. After scoring 720 marks, your rank is 80. Which one is good? 680 is good or 720 is good? So obviously, always and always, whenever you are thinking about the NEET exam, just think about the rank. Just think about your rank. If your rank is good, it's even if your rank is good at low marks, it's good. And if your rank is not good, if you're when the online classes will end. So online classes will end by I think 9th. 8th or 9th is the last online classes. 8th or 9th is the last online classes. Okay. So shall we move forward? Like earlier, yesterday we were discussing about what? That is the photosynthesis. So photosynthesis is nothing but a magical process, and with the help of this magical process, the plant will trap the sunlight and convert into what? And convert into the energy. And this energy is utilized by rest of the organism. Either it's a bacteria, fungus, animals, or many other organisms. So can we say that plant is the common gateway? Plant is a common gateway to trap the sunlight energy and further transfer to the earth. And at the same time, we were talking about some more points, like what to say. Photosynthesis is catabolic or anabolic process? So my answer is it's an anabolic process, because inorganic substance, or we can say small substances, chinna substances, convert into the bigger molecules. Next one is, It's nothing but the endergonic process. Endergonic process means what? Like we have to provide energy to initiate the process. Whenever you are providing the energy to initiate any process. So this is known as endergonic pathway. Next one is on this planet, or we can say in the universe. In the universe, any type of process is happening, that is nothing but the accepting the electron, or we can say donating the electron. One is accepting the electron and other one is donating the electron. So any type of reaction, any type of process occurring in the universe is nothing but the redox process. Is what? It's nothing but the redox process. So photosynthesis is also a redox process, where one chemical is donating the electron, other chemical is accepting the electron. Okay. So after likewise in this case photosynthesis, CO2 is required, H2O is required, but at the same time sunlight is also required, at the same time pigment is also required. So whenever you are having this much of component, so the plant is able to synthesize what? Synthesize organic compounds, or we can say bigger molecules. Okay. So good morning everyone. So now let's move to the next topic. And a few scientists we were talking in the last class. So what was the scientist? So I think one scientist was there, that is Joseph Priestley. Thereafter it's Moll's half-leaf experiment. So according to Moll's, CO2 is also required. CO2 is also required for what? For photosynthesis. And it was proven by Moll's by putting half part of leaf into the box, or we can say jar, where already potassium hydroxide is present. Potassium hydroxide is present, and potassium hydroxide will react with the CO2. So CO2 is no more available in the jar, or we can say box. So when it is not available, so CO2 is not converted into glucose. CO2 is not converted into glucose. So likewise we have discussed 2 to 3 scientists, Moll's, Joseph Priestley. What's the doubt, Laliteshwari? Anyway, we'll discuss the doubt as well as next one is a Joseph Priestley. Joseph Priestley, he said something about the air, like air is required or not, or we can say how photosynthesis is helping. How the photosynthesis is helping to restore the composition of air. After that, one more scientist was there, that is Egenhaus. Egenhaus said that only green part of the plant will photosynthesize, or we can say produce the oxygen. So producing oxygen indirectly we can relate with what? Producing oxygen indirectly relate with what? Indirectly relate with the photosynthesis. Achha, which topic it? So Rekhasri, it's a photosynthesis. It's a photosynthesis. Let me write the photosynthesis, and in the photosynthesis we are talking about what? We are talking about the scientific contribution. Voice is cracking. Is that true, or my voice is reaching to you? Okay, it's fine now. Okay. Now we'll move to the next part. What's the next part, or we can say next scientist? So next scientist is Julius von Sachs. So what is his contribution? He said that green part of the plant is photosynthesizing, no doubt. It's a no doubt. But at the same time, At the same time, he said that glucose is only present, or we can say glucose is found in which part of the plant? Green part, or it's a non-green part? So we can say it's a green part of the plant having glucose, and glucose and starch can be easily detected, or we can say diagnosed, or we can say traced by what? With the help of iodine test. With the help of iodine test, we can prove. So it's a conclusion. What is it's a conclusion? That glucose, can we say that glucose is the first formed product of what? Photosynthesis. Next, my question is how to store this glucose, how a plant is storing the glucose how plant is storing this glucose in the form of monosaccharides or polysaccharides. In the form of monosaccharides or polysaccharides. Good, starch is the answer. But can you tell me starch is monosaccharide or polysaccharide? Obviously, I didn't teach this, but still I'm getting correct answer. I'm getting correct answer like polysaccharides. Good. Some monosaccharides I am also getting the answer, but monosaccharide is not correct answer. Glucose is monosaccharide, while starch is polysaccharides. So here it's in the form of starch. Plant stores what? Glucose. And which part of plant, means where did you find this? So we can say glucose is synthesized in which part of the plant? In which plant part? So glucose is synthesized in the green part of the plant. In the green part of the plant. Okay. So this is how Julius von Sachs contributed to the field of this physiology, or we can say it's a plant physiology. So what is the difference between the mono and polysaccharides, Rekha Sri? So Rekha Sri, the main difference between the monosaccharides and polysaccharides is mono means what? It's a one. Poly means it's a more than one. When you are repeating something, so that repetition, or we can say whatever you are repeating is mono. And after repetition, whatever you are getting, it's a poly. So monosaccharides, polysaccharides, peptide becomes polypeptide, peptide becomes polypeptide. My voice is cracking. Everyone is having the same. Glucose and starch. Srikant, glucose is monosaccharide. Glucose is what? Glucose is monosaccharide and starch is polysaccharide. Why? Because repetition of glucose will give you what? Starch. And again, whenever you need this glucose, just break this what? Starch. After breaking the starch, you will get the simplest unit. That simplest unit is monosaccharide, and that is a glucose. I am not talking that glucose is only monosaccharide. Other than the glucose, other monosaccharide can also be there. Okay. Can we move to the next? Obviously, actually monosaccharide and polysaccharide is not a part of this. Simply I gave some brief point regarding the monosaccharides and polysaccharides. After that, one more scientist was there. One more scientist was there. What is the name of the scientist? What is the name of the scientist? So I think it looks weird, or we can say it's a totally different name. So the name is T.W. Engelmann. T.W. Engelmann was the scientist, and his contribution is like we can say most important. Its contribution is kind of magical in the world of photosynthesis. So what he said? He said that a lot more light is falling on this plant. A lot more light is falling on this plant. But what fraction of light is utilized in photosynthesis? Did you get my point? The amount of light which is falling on this plant is not 100% utilized in photosynthesis. Only a fraction of light is utilized in photosynthesis. So that fraction of light, can we call it as an action spectrum? So one term he has given. What is that term? That is action spectrum. So what is action spectrum? So action spectrum is whatever the fraction of light utilized in photosynthesis. Using prism, Nagaraju, good. Using prism. So here, first thing is he has given a concept. What is that concept? So the concept is action and spectrum. So spectrum is what? Spectrum is, it's a kind of graphical representation of light. Okay. So here we can say it's a graphical representation of light utilized in what? Photosynthesis. Obviously not all, or we can say 100% light can be utilized in photosynthesis. If 100% light is utilized in photosynthesis, then obviously the plant can produce more and more. But obviously it is not true. Or we can say none of the system on this planet is 100% efficient. None of the system in the universe is 100% perfect. So if someone is saying I am perfect, obviously it's a big lie. It's a big lie. No one is perfect. Obviously some loopholes, or we can say some lag point is there. Okay. So that's why if you are not perfect, don't worry about that. Or we can say don't be ashamed of you that I am not perfect. No one is perfect in the universe. And I think every one of us belongs to the same planet, that is universe. Next one is what else we can add. So he illuminated means what? So let's say this is a prism, and prism is having characteristics of what? To split the light based on the what? Based on the wavelength. So it is nothing but the white light. It's a white light, and this part is prism, and whenever this white light is passing through the prism, it is splitted. It is getting splitted based on what? Based on the wavelength. Based on the wavelength, it is splitted into what? So this much of color. color. And if you're talking about the VIBGYOR, means that is a violet to red. Violet to red. The wavelength is increasing or decreasing? Wavelength is increasing or decreasing? Wavelength is increasing or decreasing from violet to red. So can we say that wavelength is increasing? Wavelength is increasing. Good, I am getting answer. So here we can say increase in wavelength. Increase in what? That is a increase in wavelength. And obviously, if we are putting here, or we can say started culturing, the T.W. Engelmann started culturing on the and this is nothing but a, let's say it's a box. Let's say it's a box. In this box, what is there? One algae is there. One algae is there. One algae is there. What? It's written from. What I have written is. No, this white light. This white light, while splitting, it should be in what? It should be in this order, or we can say it's a VIBGYOR. And here it's an increase in wavelength. So violet is having more wavelength or it's a less wavelength as compared to red. So violet is having the more wavelength, and this one is a. So violet is having less wavelength and this red is having more wavelength. Okay. After that, now I just put one more thing. That is a green algae. Green algae. And this green algae is nothing but the what? This green algae is the name of the green algae is what? It's a cladophora. It's a cladophora. Okay. See, actually, what I am writing, it's a fine like a VIBGYOR. My main point is to write all the colors, or we can say all the visible, or we can say this is known as PAR. That is a photosynthetically active radiation. And I have arranged in what? Arranged in the increase in wavelength. Arranged in increase in wavelength. I am not just putting all the things according to the book, or we can say NCERT. Simply I am just putting what? This is the white light, and this white light is split into this. And what is the direction? So that's why I have given this direction. That is an increase in wavelength. Increase in wavelength. So that's why it's a true. That's why it's a true. Yes, it can be a Spirogyra. Like whoever can perform photosynthesis, we can put into here. We can put into here. After this, he has like T.W. Engelmann was quite intelligent, we can say. So initially he placed aerobic bacteria. Initially he placed what? That is aerobic bacteria here. So can we say that aerobic bacteria requires what? Oxygen for what? Oxygen for respiration. Oxygen for respiration. So if it is respiring more, means can we say that it will grow faster? It will grow faster, and it is dividing by what? By diffusion. Means 1 becomes 2, 2 becomes 4, 8, 16, 32, 64, 128, 256. Likewise, it will grow. After that, after some time, like after 1 to 2 days, what he has observed. Earlier, what is the condition of bacteria? So he said that all the bacteria is uniformly, all the bacteria was uniformly distributed. uniformly distributed. But after 2 to 3 days, what will happen? What will happen? In this case, after 2 to 3 days, all the bacteria, or we can say aerobic bacteria, is shifted to one side, or we can say accumulated on one particular side, So what is that particular side? According to him, he observed that most of the bacteria is shifted near the blue and red part. So firstly, all the bacteria will be shifted to this one region, and after that, in this case, it is shifted to this region. So can we say that this bacteria is shifting to this region because what? Because all bacteria requires oxygen, and oxygen is coming from where? Oxygen is coming from photosynthesis. And photosynthesis takes place in all type of light or particular type of light. So can we say that in blue, or we can say near to the blue and near to the red, the photosynthesis is more. That's why all the bacteria that were earlier presented uniformly, now it is shifting towards one zone. This explains what? This explains near the blue and red, maximum photosynthesis occurs. So if the question is coming, do all region provide same amount of oxygen, or we can say will provide same type of photosynthesis? Do all wavelength produce same amount of oxygen? Do all wavelength produce same amount of photosynthesis, or we can say same quality of photosynthesis? Obviously, my answer is no. Why? Because after seeing this, I can say what? That near to the blue and near to the red, the photosynthesis is more as compared to other region. So likewise, can we draw a graph? Can we draw a graph like this? Can we draw a graph like this? If you are putting like this, so you will get a graph. Hansika, like which part you are asking me to explain? So this is the simple fundamental. This is the white light. White light is passing through what? White light is passing through the prism. And whenever it is passing through the prism, all the light will be aligned according to what? According to the wavelength. And this is nothing but the Vibgyor, or we can say this is nothing but the increase in the wavelength of light. After that, just get a bucket. And in that bucket, what is there? In that bucket, this cladophora is present. Now, this cladophora is a green algae, so it will start absorbing the sunlight. After that, what will happen? Now, I placed a few aerobic bacteria. Now, initially, all the bacteria was in the uniform, or we can say present uniformly. But after 2 to 3 days, here you can find the shifting of the bacteria, and it is accumulated to this only part. This only part. So can we say that if you are moving from this part to this part, then I can say all the bacteria is shifted to this. Why it is shifted to this? Now we'll go back. So this part is coinciding what? Red one. And this part is coinciding what? It's a blue one. And this part is coinciding what? That is a green and yellow. Means in this case, the rate of photosynthesis is very less. In this case, rate of photosynthesis is more. So we can say that not all wavelength contributing the same amount of what? Same amount of photosynthesis, or we can say same quality of photosynthesis. Okay. Now, can we move next? So, is that clear? What he has done, that is a T.W. Engelmann. So T.W. Engelmann simply said that X-ray spectrum is one thing, and in that X-ray spectrum, we can plot the graph. And I can say properly what type of light is absorbed more and what type of light is absorbed very less. Okay. Now we'll move to the next one. Once T.W. Engelmann is done, thereafter one more is there, that is a Cornelius, or we can say it's a Van Niel. So he was the scientist. After that, what is the main problem among the scientists? Let's say in this whole chat box, or we can say approx 200 students are there, let's say. And all of you are working on photosynthesis. And if you are talking about the equations, so can we say that this is the equation? This is the equation. Thereafter, you will get glucose. Means glucose is having this, and like this. This is the equation of photosynthesis. But at the same time, all of you are disturbed, or we can say all of you are confused. Confused means what? Like this oxygen. So this oxygen is coming from where? Either it is a part of water or it is a part of CO2. Can you tell me the oxygen evolved in photosynthesis is a part of water or a part of CO2? Okay, you people know, means you are more intelligent than what? You are more intelligent than Cornelius Van Niel, Julius von Sachs, Joseph Priestley, or we can say whoever is working in photosynthesis, you are more intelligent than that. So now, but how he has concluded that this oxygen only coming from where? This oxygen only coming from water, not from the CO2. Okay. So let's think. He was experimenting on few bacteria, that is purple sulfur bacteria and green sulfur bacteria. Means that is a photosynthetic bacteria. And he start diagnosing, or we can say he start analyzing this experiment. In this experiment, again CO2 was there. But this type of bacteria is not utilizing water. This type of bacteria This type of bacteria is not utilizing what? Water. Instead of water, some XYZ substance this is utilizing. After that, all scientists were waiting for what? If it is a photosynthesis, means scientists were waiting for what? Scientists were waiting for the one is glucose and one is oxygen. One is glucose and one is oxygen. But he got only one thing. He got only one thing, that is organic substance. But instead of what? Instead of oxygen, what he got? Instead of oxygen, he got either you can say in the form of sulfate, or we can say it's a sulfur. That depends on the type of organism, or we can say bacteria we have considered. Okay. Now can you compare between these two equations? If CO2 plus H2O is there, what we are getting? Oxygen we are getting. But instead of H2O, what I placed? That is H2S. H2S I am placing. In this case, I am getting the glucose, or we can say organic substance in both the cases. But what I am not getting? What I am not getting, it's nothing but the oxygen. Instead of oxygen, what is there? Instead of oxygen, what is there? So it's nothing but a sulfur, or we can say it's a sulfate. So what we can conclude from this part? What we can conclude from this part? That oxygen is coming from, or we can say oxygen is a part of water or CO2. So oxygen is a part of water, not from the CO2. So here we can say it's a type of conclusion. It's a conclusion. Oxygen comes from water, not from CO2. Now the scientist was happy because the almost confusion is gone. So all were happy. All were happy. But at the same time, some scientist is there, like whose main task is to pull the leg, or we can say to criticize others' work. To criticize others' work. So he said that, no, I'm not agree with you. I'm not agree with you that it is coming from the water. It is coming from the water, or we can say it is coming from the CO2. So some other scientist comes and he experimentally proved that. Oxygen is coming from where? That is a water, not from CO2. So here it's a few group of scientists was there, but directly I'm just writing one scientist. Writing only one scientist, that is the name of the scientist, who is Ruben. So Ruben, Hasid and Kamen was there. So combinedly he has experimented, or we can say they have experimented one thing. So to eradicate, or we can say to remove the confusion. To remove the confusion, he has taken two type of oxygen. He has taken what type of oxygen? That is a two type of oxygen. So one is 16 and one is 18. One is 16 and one is 18. So simply I am not writing 16, but I am just properly writing 18. So let's say this is nothing but 18, O18. So he leveled the oxygen O18 in the water. After this experiment, what will happen? So again, same thing, that is a C6H12O6, or we can say it's a glucose. Oxygen was there. But at the same time, what happened? The oxygen is 18 wala oxygen or 16? So he found that, or we can say they find that it's nothing but the O18 was there. O18 was there. So can we say that this oxygen is coming from water, not coming from what? Carbon dioxide. Because in the carbon dioxide, what type of oxygen is there? So it's a 16 type of oxygen is there, while 18 type of oxygen is only present in water, and that O18 is, or we can say the same oxygen, the same O18 is present here. So what is the conclusion? Conclusion is oxygen is coming from water, not from the CO2, and this is the experimental basis. This is nothing but the experimental basis. Earlier it was like a kind of hypothesis, but Ruben and Kamen experimentally proved that oxygen is coming from where? Oxygen is coming from water, not coming from the CO2. Okay, so is that clear? So till now, how many scientists are there? So I think we have started the moles. Next one is a funny scientist, Joseph Priestley, Jan Eggers, thereafter von Sachs, thereafter thereafter it's a Van Niel, and the last one is nothing but the Ruben, and Kamen. So these are the scientists who were somehow involved in photosynthesis. Okay, so is that clear? Now we'll come to one more point. One more point is like, where does this photosynthesis occurs? Like, is this process which is occurring in root part, stem part, leaf part, fruits, flowers, where it occurs? Or we can say it occurs in all part of the plants, or whether it is restricted to only few part of the plants. That we will talk. So now, but before going to that, I need to differentiate, or we can say break the whole process, that is the photosynthesis process. We can divide this whole photosynthesis process into two parts. The first part is, one is light dependent reaction, or we can say it's a light reaction, simply we can say. And other one is what? Other one is light independent reaction, or we can say it's a dark. So one is light reaction and one is dark reaction. So which occurs in light? Which occurs in light? Can you tell me? Which occurs in light? Light reaction or dark reaction? Which occurs in light? Light reaction or dark reaction? So light reaction and dark reaction both can occur in light. Both can occur in light. Okay. But this is the light reaction. Achha, is that possible that light reaction occurs in dark? Light reaction occurs in dark? So obviously no. Obviously no. Good. So now, due to some correction problem, But is that clear? Like, am I audible? Okay, now let's start. One is light dependent reaction and one is light independent reaction, right? So firstly, now tell me, light dependent reaction occurs only in light or it can occur in dark also? I'm just making some differences. It occurs only what? Only in light. Good. Only in light. Now, what is its difference? It can occur both light as well as in dark. So here we can say it can occur in both dark as well as what? It's a light. After that, what else we can say? Oxygen comes during the daytime or nighttime? Oxygen comes during daytime or nighttime. So we can say during light dependent reaction, or we can say from light dependent reaction, the oxygen comes. So oxygen only comes when? During the daytime. So here we can say this light reaction, it is related with what? It is related with pigment. Means you should have the pigment. Or anyone who is performing photosynthesis, or we can say it's a light reaction, should have what? That is a pigment system should be there. While in this case there is no requirement of pigment. So this dark reaction is also known as biosynthesis. Or we can say it's nothing but the biosynthetic phase. It's nothing but the biosynthetic phase. Now, in this case, what we can say? Energy is generated. While in this case what? Energy is utilized for the formation of in this case generation of energy. And what is the form of energy? So the form of energy is, we are having two coins. We are having how many coins? So it's a two coins. We are having two coins. What is that coin? So one is ADP and other one is NADP H plus. Okay. So how many coins the plant is having? Or we can say plant is generating for the photosynthesis. So it's only two coins. So these are the two coins. In this case, ATP and what? ATP and NADP H plus is utilized to what? To synthesize glucose. To synthesize what? To synthesize glucose. Now, we all know that this photosynthesis occurs where? Inside the chloroplast or outside the chloroplast? Inside the chloroplast or outside the chloroplast? So I hope I will get the answer correctly. So inside the chloroplast or outside the chloroplast? Inside the chloroplast or outside the chloroplast? Photosynthesis. Yes, good. Now we are inside the chloroplast, inside, so most of the answer I am getting correct. So it's inside the chloroplast. But again, if you imagine about the chloroplast, so the chloroplast is having few thylakoids, or we can say coin-like structure, stoma, lamellae, or overall we can say inside part of the chloroplast is divided into two. One is stroma and other one is a membranous part. One is stroma and other one is a membranous part. So Hansika, what is biosynthetic? So biosynthetic phase means what? Bio means it's a living. Bio means it's a living, and synthetic means what? We are making something. We are making something. So that's why it's a biosynthetic phase. And what is synthesizing? Glucose is synthesizing inside that what? Inside the bio. So that's why we can call it as a biosynthetic phase. Okay. Now, light reaction, where it occurs? So here we can say all membranous part. So here we can say it's a membranous part of what? Membranous part of chloroplast. Membranous part of chloroplast. Next one is here. This dark reaction, where it occurs? So dark reaction occurs in which part? Membranous part, or it's a stromal part, or we can say it's a liquid part, fluid part. So here we can say it occurs, so takes place where? Takes place in stromal part of chloroplast. Stromal part of chloroplast. So these are the few things that is related to. One is light reaction and one is dark reaction. One is light reaction and one is dark reaction. Okay. So is that clear? Like somehow, because in the next class mostly we'll go further. Like in the chloroplast, what are the things are there and how it is involved in photosynthesis. But till now, just we have discussed, sir, is it stoma and the grana of the? Yes, stroma and grana. So membranous part is what? Membranous part is grana, and stromal part means what? That is a fluid part of the chloroplast. Fluid part of chloroplast. So just I am here to answer your doubt. If you are having any doubt, just write there. So write there doubt, I will answer. I'm just waiting for the doubt. Where is the stromal part present? See, stromal part is nothing but just consider this bottle. Consider this bottle as what? Chloroplast. Chloroplast. And what is there? Inside that it's a water. So consider this water as what? Water is a stroma. So in this water, what is happening? Dark reaction or light reaction? In this water, dark reaction or light reaction? So here it's a dark reaction. And inside the water, if I am putting something like I don't put this because, but if I am putting something, so that one is considered to be as what? Considered to be as a membranous part. In the membranous part, what is there? So in the membranous part, light reaction occurs. So one is light reaction and one is dark reaction. So any other doubt in which plant does dark reaction occurs? See, dark reaction occurs in all plants, or we can say any plant which is synthesizing what? Which is synthesizing glucose is having the dark reaction. Mansa, what can we conclude from light and dark reaction? From like a light, this whole photosynthesis part is not completing in one phase. So the first phase is the light reaction. Light reaction means what? It can generate the energy. After that, the same energy is utilized for what? The same energy is utilized for what? Same energy is utilized for the biosynthetic process. Biosynthetic process means what? It's a dark reaction. So can plant do this dark reaction without light reaction? So obviously it's not possible. Stroma to cytoplasm, somehow you can compare. Somehow you can compare because cytoplasm is also plasma, or we can say fluid, and in this case it is also fluid. Okay. So everyone, yes, obviously you have to buy the NCERT. So anyway, I will just hold the class, or we can say pause the class. We'll meet in the next class with some other topic. Okay. What do we call space inside grana? In space inside grana, you can call it as a what? It's a lumen. Space inside the grana or thylakoid is nothing but the lumen. So bye bye everyone. We'll meet in the next class.